There we go.
Who wants to start?
We will. Yeah, we're the most basic overview of the three papers. So ours is called Thermophiles, Early Biosphere Evolution and the Origin of Life on Earth, and the Implications for Exobiological Exploration on Mars. So the paper actually starts out talking about the origin of life on Earth, which seems kind of weird, but they said there's two ways to study the evolution for early life, and one of them is obviously in the rock record, and the second is ribonucleic acid sequencing, or RNA, or however the hell you say that.
Ribonucleic.
There you go. I have absolutely no idea what that is, and I even put a bunch of question marks on my paper.
Yeah, it transcribes the DNA. It's kind of thought to be like the first life.
Well, like when you make a protein, the little pieces go in, and they the DNA unwraps, and then a new section is formed along one side. It's called messenger RNA because it's the exact opposite of the DNA.
So how would you use that for?
To make a protein.
How would you use that to trace the evolution of life?
Because it records genes, and you can record the evolution of genes.
Okay. Well, I'm glad you guys know what it is, because I didn't.
You know.
It's alright.
Kind of.
Just go read the wiki.
So after that, they said that based on their RNA studies, they found that bacteria is basically probably the root of all life. And the most ancient life that we have is our hyperthermophiles, which are high temperature species that grow at greater than 80 degrees C, and they're analogous to modern black smoker systems of the deep sea on Earth, obviously. And they're also considered chemolithoautotrophs. What those are is they are capable of synthesizing organic material from inorganic material. Now what they said is
Give me that rock.
Real life another day. Like, how cool would it be to be photosynthetic? Just like look at the sun and be like, it's delicious.
Alright.
Be cool, right?
It's true.
I guess so.
Sorry.
Are you done?
Yeah.
So what they also said was that it's possible that the reason that these hyperthermophiles and the chemolithoautotrophs, maybe that's as far back as they go because of impact events during the heavy bombardment, which they don't even mention the late heavy bombardment, because they talk about life first appearing between 4.2 billion years ago, and that these impacts basically create high temperature bottlenecks on Earth. They cause everything but high temperature species to die. So that may be why we don't have any evidence of low temperature species back that far back.
So the impacts cause lower temperature life to die.
Right.
Just because there's impacts all the time and space and tons of heat on the surface.
That would be my guess. They didn't really get into the specifics about that. They didn't at all. So, but they did say, and I don't know anything about biology, that low life temp is easier to maintain and easier to grow. And it could have definitely happened at this 4.4 to 4.2 time period, but it may not have. No record of it may have gotten past the impacts. So, one of you guys want to take over from there?
Sure. So, I guess this has implications for Mars. Mars has the Noachian and Hesperian ages on Mars are the same ages as what the Archean is on Earth. So the study of the Martian trains can help fill in the gap of early evolution on Earth. We could figure out if there was any evolution or whatever going on Mars. Let's see what else. I don't know if they said they did. I think they did. Found evidence for some hydrothermal systems, right? Said that
Well,
did
they
find
said
some.
there's some terrain that may be hydrothermal in origin, and then I've looked up, and there are some newer papers like from '09 and '10 that go into that a little bit more and are looking for hydrothermal systems. But it's hard to tell because they haven't been able to. The one paper that I looked at closer said that it's hard to tell because they haven't found any traces of pyrite yet, which would probably be one of the major minerals found there. So I don't know that that's complete solid evidence that there are hydrothermals.
Or could it just be that most of it's subsurface? I think I'd imagine there are plenty of hydrothermal systems on the planet. It's just part of the system.
Yeah, well, that's the other thing that they state. But we're talking about like Noachian,
Okay.
like
So
Archean age,
ancient
ancient,
hydrothermal systems.
and they're related to the volcanic systems. So
Gotcha.
they're much older, not now.
Okay.
Go ahead.
Yeah, these areas could have supported the thermal files. And, they've modeled some groundwater systems, like expected groundwater systems on Mars. And some of the subsurface heat sources have hydrothermal systems associated with them. And we believe that this could be a location for extant life on Mars. But in order to preserve these little guys, you gotta have rapid burial of the microbes. And on Earth, they look at like lake beds, ancient hydrothermal systems in the lake beds or whatever, where the precipitation came out. They look at these places for really good preservations of life, microbial life anyways. And then just again, they said that they found hydrothermal systems and evaporates both on Mars. They want to send the next rovers too.
So the best places find life would be the places that may be smaller that we can't even see right now. So how we always need higher resolution stuff. So again, same thing. But another point, like those would be the best places in the rovers, the places that have these kind of activities. But of course, some of them are the hardest places to get to.
Land things there.
Some of this, the paper was written in '98. Some of it has come true, like where they did find. We had a paper on. I forget who wrote it, but we had a paper on the evaporates that they found everywhere. So that might be a good place to go look for these. But they said that maybe through spectroscopy, they might even be able to find traces of bacterial life through that. But I'm not sure.
Yeah, it's like the carbon and stuff like that, the carbon isotope enrichment. And those are kind of the markers that tell maybe what was there. Those things.
And there's some minerals that are purely biotic, like they're from biotic processes. So if you find those minerals, which might be fired with the spectroscopy, because they might be in really low quantities. But if you find them, then that would be a good sign. But I think the cool thing is just this little section says even if there's no life on Mars, that it's still really important for us to evaluate the Noachian and the older terrains because we don't have that record of what a lot of those Archean age things look like on Earth. So we don't know a lot of the early chemical evolution on Earth, like even the abiotic chemical evolution. So if we knew that, and Mars could give us clues to that, then maybe we can know more about how life started on Earth.
Yeah, I also think that that's kind of a big fault of this paper, is that they start with life on Earth. Because we have, like he just said, we have no idea what they may have looked like then, so we might be looking for the complete wrong things.
Yeah, I mean that's definitely a possibility, but you gotta start somewhere.
Sure.
Yeah.
So you gotta start with life on Earth.
I just
Like we have.
right. I just wanted to point that out that is a pretty big, could be an issue.
I know there's always that one of, I mean, that is really important because then why doesn't Mars have life? If Mars didn't have life, and there's a
Well,
whole
and
new
then
set of questions. that
why
people
doesn't it
ask.
have life like Earth has life? I mean, even if it has this completely different forms than anything that we would see on Earth, there is still a question of why. Why?
Seems to
It
me,
just been preserved too.
Right.
seems to me the evolution cast. If let's assume that Earth and Mars started on the same evolutional path with microbes, it seems like with tectonics and liquid water on the surface here and a magnetic shield, so to speak, that we were able, evolution was able to keep going. And on Mars, they don't have any of those things, which probably stopped it in its tracks.
Possibility, or it could just taken life in a completely different direction.
Or it didn't happen at all.
Yeah, there's just so many possibilities. It's mind-boggling.
Yeah.
It'd be cool if they were like huge bacterial mats.
Or like
This or
like underground Mars
They're kind of
worms
freaky.
producing
that.
methane.
Yeah.
Yeah.
Exactly.
man.
There's the source of that methane.
Craboids. Tremors. Oh my god.
No, they can't bury. They can't dig through hard rock though.
That's very true.
Yeah, but
They,
they could
they
live
live
in
in
the
the
regolith.
regolith.
Could be in the regular.
We're such nerds.
What are those big worms from never mind. Can't think of the movie now.
Oh.
Had Sting in it.
Sting?
Oh.
The wrestler or the singer?
Which band that we can ask that question?
The singer.
The singer.
Sure, the wrestler was a better
First.
actor.
Never mind.
I'm sure the wrestler was a better actor.
There was.
A giant worm, yeah.
It was a giant worm
One.
during that banana song.
It's gonna bug me.
You guys got anything else?
That's about all we have.
I would pretty
We'd
much
like for
just
you
that
guys to
paper.
grill us for a little while if you can.
Well, I mean,
I can't.
I can't, yeah,
That's
because
the
I'm
problem.
not, I guess, trained in biology that much, and plus, like, our paper goes over a lot of the same key points that yours kind of did.
That's kind of why I said we should go first, just
Yeah.
because it is just
Steal all the points away from us.
Pretty much.
yeah.
Bastards.
Yep, and mine covers a lot of the same points too.
So we basically go
Well, that was my real reason for wanting to go
Here we
first.
go again.
It's really funny how fast they think exploration and stuff's gonna go.
Well,
Obviously,
apparently it
they think
was.
it's economy tanking.
No, but I mean, like, even
Right.
if they had, like, if the economy didn't do that, we did launch a mission in 2005 to retrieve.
No, but it
bring
was
back,
scheduled
but-
in '98 when they
Why didn't they do that?
money.
Well, shouldn't they think of that instead?
Maybe they realized when they started getting the tests and FEMA stuff back that they didn't actually have a high enough resolution yet to.
It is kind of weird because that was during the Bush administration, and he was like a real big like pro NASA person. You know,
That's the stupid thing.
but you'd think that these missions would have like come to fruition.
He was too busy.
He's too busy.
hanging out on the ranch, not governing our country.
We don't need to go there, but
So we should talk about
Yeah,
George
we-
W. Bush for the next.
We need to
40
go back
minutes.
because I'm not even gonna
So,
start.
So,
We'd get a lot more hits
So
on
do you
YouTube
think?
if we did.
do you try to
My favorite?
wing it?
Yeah. I'm gonna go for it. I'm flying solo, so.
Which paper was yours?
Horn?
Irda Hornet.
Hornet?
The microbial world in the case for Mars.
Weird.
Yeah, where is she? Germany.
Microbiome.
So, this is also an old paper, but I don't know how relevant. That's really
Yours
gonna
the
be.
newest paper.
Yeah, mine is the newest paper. This
Yeah,
was
it's still
as
old.
recent as 2000. So they start out with the basic premise of assuming that early Mars is pretty similar